Hi guys, Miss O'Connell here. So today we're going to be doing an activity based on Physics Day. So you can see here that we are currently riding the big wheel. Hopefully yesterday we got to take a chance to look at the virtual reality segment that was posted about Virtual Physics Day yesterday, in addition to those other links. But today we're going to be focusing on a circular motion based ride activity from Physics Day to kind of review and bring together everything that we have talked about so far. Okay, so this activity is going to count as a quiz grade. We're going to complete it in groups and review it during our live class today. If you cannot attend the live class today, that is okay. You're just gonna have to do the activity on your own time and submit it to Classroom. Okay, so here we see that we are currently riding the big wheel. Okay, and this comes from the link from the activity that was posted in Classroom yesterday. And from our assignment in Classroom that is posted today, we're gonna take a look at this activity. Okay, so this data is already filled in for you because you'd have to collect it at the park using something that we call an inclinometer, which basically allows you to figure out how high or far away something is based on estimated values. So you would pace off the distance from where you're located. Okay, you need to pick a location in which you can see the top of the big wheel. Okay, so you'd have to stand a distance that's far enough away that you'd be able to see the top, but as close as possible. So once you determine that distance, you'd use an inclinometer based on your point of view, your perspective, and you'd create a straight line from your eye to the top of the object. Okay, so you'd close one eye, you'd basically point the inclinometer up to the top of the tower, and then you'd use a hanging mass to determine the angle of inclination. Okay, so what angle must you tilt the protractor at in order to see the top of the object within your perspective? Once you determine that angle, you'd pace out using your feet how far away you're located. And this is obviously an estimate. There's a fence around the ride, so we'd have to estimate, and we do our best there. So we pace off a number of feet between that specific location where you can see the top of the object, but you're as close as possible. You pace off from that location to as close as the ride as you can get. And then we convert that using trig to figure out how tall the actual object is. Okay, so that's an experimental calculation of the height of the object. Okay, so we would do that before we get on the ride. We'd estimate that each one of our paces is about 2 feet in length. It took us 68 paces to get to the actual big wheel, and the degree that we find above horizontal with our handy dandy tool, which we'd have in our backpack or our pocket, was 50 degrees. While we're on the ride, we would time how long it took to make one revolution, aka we would time the period. And it was when the big wheel's in motion. So once you start moving, if you start a location and end at that same location, it would take 33.25 seconds while the big wheel is in motion. The other two pieces of information that we would collect at the park obviously has to do with you in particular. It'd be your weight. Okay, so you take your mass, you'd multiply by 9.8 to get your weight in newtons. Okay, so you'd first take your actual weight. If you don't want to use your weight, that's fine. You can use 140 pounds. Okay, so if you don't want to put your actual weight on there, just use 140 pounds. That's my weight. So you take 140 and you convert to newtons. Okay, so simple conversion there. Then you multiply by 9.8 to get your mass. So again, we're going to do this in groups and then review it during class today, but if you are not attending, right, this is your explanation as to how to do the activity. So you want to convert your mass from pounds to newtons, and then from newtons to kilograms, but divided by 9.8. Okay, this ride activity was written by a classmate of mine. So AP Physics C students every year either write or revamp a ride activity for Physics Day. So this actual activity was written by my classmates in AP Physics. So it's a little funny. Some of the directions, because they're written by high school students like you. Okay, so first page is the measurements. Only thing you need to add is your weight. Okay, the activity walks you through step by step how to complete it. The equations that you need are located on the left side of the actual question. So for example, for 1D, it says use equation to the left to calculate the height of the ride. So you take the tangent of 50 equals the height of the ride divided by the distance from the base, which you calculated or measured rather in 1C. So you take tangent of 50 in degree mode in your calculator and you multiply by 136 to get the height of the ride in feet. In 1E, it says convert 1D to meters. So you would use this conversion, which is located directly over here to the left. So all the equations that you need are directly on the worksheet. You just need to plug in the numbers to formalize the calculation. So you convert your answer from D into meters using this conversion rate. And then for part F, to find the radius of the wheel, you take the height, which you determined in 1E, and you divide by 2. Right, the height's basically the diameter, so the radius would be half of the diameter. Okay, and then the rest of it's pretty straightforward. Okay, you need to find the tangential speed of the object while it's moving in uniform circular motion during that 33.25 second interval. So you take 2 times pi times the radius you calculated in 1F, the period you measured under your calculations, and you calculate the tangential velocity. You then convert that to miles per hour. Okay. Number 3 is a review of gravitational potential energy. Okay, so equations are again there for you. 2 ways to solve number 4. This is again a review. You can use the big 4, kinematics, or you can use conservation of energy. Okay, and last step, angular velocity, which just means the rate at which it rotates. You take the tangential velocity and you divide by the radius. You calculate a tangential velocity in number 2, and you divide by the radius in which you calculated in 1F. Okay, so hope to see you during class. If not, please submit the activity to Google Classroom before class tomorrow. Have a nice rest of your day, and I'll talk to you guys tomorrow.